Have you ever wondered what it would feel like to weigh 1 trillion pounds? Well, you can find out if you travel to a black hole. What are they? How do they come to be? And where do they exist? I'll explain formation, location, and basics of a black hole. During the normal life cycle of a star, there is an outward pressure because of the nuclear fusion that keeps the star from collapsing under its own gravity. When the fusion process stops in a star that has to be at least 10 times greater than the size of our own star, a supernova explosion occurs. The outer layers of the star are blown away, the core remains and collapses, forming a black hole. When the mass and density of an object reach a certain point when even a beam of light can't escape its gravity, we call this a black hole. Because no light can leave a black hole, we can't see them with the naked eye. The Earth would have to be compressed to the size of a marble to be dense enough to be classified as a black hole. For a star to be a black hole, it has to be at least 10 times the size of our own sun. And supermassive black holes can be millions times the size of our own sun. The massive gravity of a black hole can change the time and the space around it and even stop time. Currently, there are 14 known black holes in the universe with an estimated millions. And Einstein's theory that a black hole's radius is directly proportional to its mass was proven true. The nearest black hole to us is 8,000 years away, and it's in the center of our galaxy, and it's called Cygnus X1. And all the big galaxies have a supermassive black hole in the center. If it can't be seen, how do we know they're there? Hot gases and materials falling into black holes give off X-ray radiation, which can be seen using specific instruments. We can also measure the speed of stars rotating around the center of the galaxy and determine that something with immense mass and not that much volume that they're orbiting around. According to Einstein's theory of general relativity, all objects with gravitational force bend light. This theory was proven in 1919 during a solar eclipse when stars that were behind the sun could be seen because the sun's gravity bent the star's rays. And black holes have so much gravity that light beams are bent when they're within a couple 100,000 miles of the hole. And because of the black hole's immense gravity, if it gets any closer than that, it gets sucked into the black hole. So around it is a black disk where there's no light at all. And when we're able to orbit a black hole, we will be able to see multiple images of the same star distorted because the black hole will bend many rays of light into our eye. And this is kind of what it would look like. So if star's back here and the black hole is here, the light ray that's coming out this way will be bent down. And because light travels straight usually, we will see the star up here. So I'll kind of draw up another little example. Go with blue eye. And black hole here. And then star over here. And this star is going to give off light rays in all different directions. You can kind of imagine that it would be more of a three-dimensional shape, so it would be more like a ball. And so light rays are going to come here, get sucked into the black hole here, get sucked into the black hole. But the ones that are up here are going to go around, go into your eye, so they're going to bend. And they're here. So you can imagine that on all 360 degrees of the black hole, the ball basically. And what do you imagine you would see if you saw all these light rays coming together, bent by the black hole? What kind of shape do you guys think that you would see?
Ring.
A ring, that's correct. So because of this, you're going to see multiple images of it. Let's say that this is the only star in the night sky, which it's not, but in the black hole here, you're going to see multiple images of the same star distorted because of the black hole's immense gravity. And here's some like artist's impressions of what that would look like. This star and this star here are the same star, but they're just distorted by the black hole's immense gravity. And then here you can kind of see the gravitational ring right here. same star right here. And this effect is called gravitational lensing. Now that I've explained the whereabouts, making, and basics of black holes, I hope you're interested enough to do research on your own. Any questions?
How does time stop?
Time stops because space and time are directly related, and because gravity of a black hole is so immense, it starts to mess with space and almost like shrink it or compress it. So eventually the time is so messed with, it's hard to explain, but it's like, it's so shrunken and compressed that eventually time just stops.
If a clock went into a black hole and you looked at a telescope, what would you see?
So from your point of view, if you were watching it with a telescope, the clock would be going and you would see time start to, so you see the second hand, and time would start to tick slower and slower as it got closer to the black hole. And as you'd be watching it, the clock would be, so let's say it's like a silverish gold clock. As it got closer and closer to the black hole, it would start to become more red because the light that's coming towards you is starting to slow down because of the black hole's immense gravity. So the clock would start to look red, and eventually it would start to go slower and slower, and it would just look like it would just stop.